Hello children, welcome back to the science video session. In this science video session, you are going to learn the lesson Chemistry in Everyday Life from Chemistry of Standard 8. Come, let's move on to the video session.
Unit 15 Chemistry in Everyday Life. Introduction. When we hear the word chemistry, we think of chemical reactions conducted in the laboratories. But chemistry is beyond that. We can find chemistry in everything in our surrounding. It is in the air we breathe, the food we eat, and everything we use in our daily life. Our body is made of elements like nitrogen, phosphorus, hydrogen, oxygen, calcium, potassium, sulfur, magnesium, etc. All the chemical reactions taking place in our body are due to chemistry. Our whole life is dependent on various chemical compounds. Among them, hydrocarbons are the most important one. They find application in our daily life. We can say that the old civilization is driven by hydrocarbons because they make up the fossil fuels, petroleum, coal, and natural gas. In this lesson, we are going to study about different types of hydrocarbons, fossil fuels like petroleum, coal, and natural gas, characteristics of fuel, and solar energy and its application. Come, let's see the lesson. Hydrocarbons. Hydrocarbons are the organic compounds consisting of carbon and hydrogen atoms. They are combustible and produce large amount of heat energy along with carbon dioxide and water vapor on burning. Hence many hydrocarbons are used as fuels. Sources of hydrocarbons. Hydrocarbons occur naturally and they are found in fossil fuels like crude oil, natural gas, and coal. About 300 million years ago, plants and animals died and they were buried on the ocean floor. Over time, they were covered by silt and soil layers. Then they were buried deep inside the earth and compressed through temperature and pressure and converted to fossil fuels like oil and natural gas. These fuels are found in porous rocks which lie below large bodies of water, especially oceans. By drilling these rocks, hydrocarbons can be extracted. Hydrocarbons are present in different trees and plants also. Properties of hydrocarbons. Among all the chemical compounds, hydrocarbons have some unique properties. They are most of the hydrocarbons are insoluble in water. Hydrocarbons are less dense than water, so they float on top of water. Most hydrocarbons react with oxygen to produce carbon dioxide and water. Hydrocarbons can be gases, example methane and propane, and can be liquids, example hexane and benzene, and can be waxes, that is paraffin. Hydrocarbons are capable of making bonds with one another. This property is known as catenation, that is chain formation. Due to this property, they form more number of complex molecules. Types of hydrocarbons. In hydrocarbons, carbon and hydrogen atoms are linked together through different chemical bonds. Depending on the bond between these atoms, there are a number of hydrocarbons. The four general classes of hydrocarbons are alkanes, alkenes, alkynes, and arenes. Some of the common hydrocarbons are methane, ethane, propane, butane, and pentane. Methane is the simplest hydrocarbon in which four hydrogen atoms are linked with one carbon atom. It is a colorless, odorless, and inflammable gas. It is an eco-friendly fuel because it does not produce any harmful products. It is used as fuel in electricity generation. Methane is also known as marsh gas as it is present in marshes. Dead and decaying plants and animals releases methane gas. It is a renewable source of energy. Sewage sludge can also be decomposed by microorganisms to produce methane gas along with impurities like carbon dioxide and hydrogen sulfide. After removing these impurities, methane gas can be used as an efficient fuel. Propane is an odorless and highly inflammable gas. It is heavier than air. It is liquefied through pressurization and commonly used as LPG, liquefied petroleum gas, along with butane. Propane is used as fuel in heating, cooking, and vehicles. Propane can also be used as refrigerants. Butane is a gas at room temperature and atmospheric pressure. They are highly flammable, colorless gases that quickly vaporize at room temperature. Butane is used as fuel gas and propellant in aerosol sprays such as deodorants. Pure forms of butane can be used as refrigerants. Butane is also used as lighter fuel for a common lighter or butane torch. Pentanes are liquids with low boiling point. They are used as fuels and solvents in the laboratory. They are also used to produce polystyrene. Natural gas. Natural gas is a naturally occurring hydrocarbon gas mixture consisting primarily of methane along with other higher alkanes and a small percentage of carbon dioxide, nitrogen, and hydrogen sulfide. If the natural gas contains lower hydrocarbons like methane and ethane, it is called dry gas. If higher hydrocarbons like propane and butane are also present in the gas, it is called wet gas. Natural gas is always found above the oil in the oil wells. This gas is trapped inside the small spaces in underground rocks called reservoir. Conventional natural gas can be extracted through the drilling wells. Natural gas can also be found in reservoirs with oil and is extracted along with oil. This is called associated gas. Natural gas is a fossil fuel used as a source of energy for heating, cooking, and electricity generation. Natural gas occurs in Tripura, Rajasthan, Maharashtra, Andhra Pradesh in Krishna and Godavari basins, and in Tamil Nadu, Kaveri Delta. It is also formed by the decomposition of organic matter in marshy areas and waste sewages. The natural gas formed by this contains mainly methane. Uses of natural gas. Natural gas is used as an industrial and domestic fuel. It is used in thermal power stations. It is used as fuel in vehicles as an alternative for petrol and diesel. When heated, it decomposes and forms hydrogen and carbon. Hydrogen, thus formed, is used in the manufacture of fertilizers. It is used to manufacture chemicals, fabrics, glass, steel, plastics, and paints. It is also used in electricity generation. Do you know propane is used in LPG cylinders? Since it is an odorless gas, any leakage cannot be detected. Hence, a chemical by name mercaptan is mixed with LPG to help in detection of any leakage of LPG. Then, moderate temperature and humidity is needed to keep paintings and other ancient artifacts from being destroyed by environmental factors. Thus, natural gas is used in museums to protect the monuments. Advantages of natural gas. It produces a lot of heat as it can be easily burnt. It does not leave any residue. It burns without smoke and so causes no pollution. This can be easily supplied through pipes. It can be directly used as fuels in homes and industries. Compressed natural gas. When the natural gas is compressed at high pressure, it is called compressed natural gas (CNG). Nowadays, it is used as fuel in automobiles. The primary hydrocarbon present in CNG is methane at 88.5%. Natural gas is liquefied for shipping in large tankers. This is called liquefied natural gas (LNG). CNG is stored at high pressure, whereas LNG is stored in ultra cold liquid form. CNG has the following properties. They are: it is the cheapest and cleanest fuel. Vehicles using this gas produce less carbon dioxide and hydrocarbon emission. It is less expensive than petrol and diesel. The average composition of CNG is given in the table. Methane in 88.5 percentage, ethane in 5.5 percentage, propane in 3.7 percentage, butane in 1.8 percentage, and pentane in 0.5 percentage in CNG gas. Other gases. Apart from natural gas, there are some other gases which are used as fuel. Producer gas, coal gas, biogas, and water gas are some of them. First, we are going to see the producer gas. Producer gas is a gaseous mixture of carbon monoxide and nitrogen. It is produced by passing air mixed with steam over red hot coke at a temperature of 1100 degrees Celsius. It is used as an industrial fuel for iron and steel manufacturing. Coal gas. It is a mixture of gases like hydrogen, methane, and carbon monoxide obtained by the destructive distillation of coal. Heating coal in the absence of air is called destructive distillation. It is used in heating open hearth furnace in manufacture of steel. It is also used as a reducing agent in certain metallurgical operations. Water gas. It is a gaseous mixture of carbon monoxide and hydrogen. It is made by passing steam over incandescent coke at a temperature of 1000 degrees Celsius. Both carbon and water, which is at gaseous form, reacts with each other at temperature of 1000 degrees Celsius, gives carbon monoxide and hydrogen both in gaseous form. So carbon plus H2O gives CO and H2, carbon monoxide and hydrogen molecule. It is also called as syngas or synthesis gas as it is used to synthesize methanol and simple hydrocarbons. It is used as an industrial fuel also. Biogas. Biogas is a mixture of methane and carbon dioxide. It is produced by the decomposition of plant and animal waste, which forms the organic matter. The breaking down of organic matter in anaerobic condition, that is in the absence of oxygen, leads to the formation of biogas. It is an example for renewable sources of energy. Next, we are going to see coal. Coal is one of the fossil fuels. It is a mixture of free carbon and compounds of carbon containing hydrogen, oxygen, nitrogen, and sulfur. 300 million years ago, some plants grew into giant ferns and mosses. These plants got buried into the bottom of the soil. They slowly started to decompose and form a dense sponge-like materials called peat. Over time, peat was compressed due to high temperature and pressure and coal was formed. As coal contains mainly carbon, the slow process of conversion of dead vegetations into coal is called carbonization. Extraction of coal. Coal is extracted from the coal beds found below the surface of the earth. Coal found inside the earth is broken into pieces by explosives and brought above. Depending on the depth of the coal bed, coal is extracted in two ways. One is surface mining and another one is underground mining. Surface mining. If the coal beds lie within 22 feet of the earth's surface, the topsoil is removed and coal is dug out. This is called surface mining. Then, underground mining. In some places, coal beds are found very deep inside the earth. In that case, underground tunnels are made to get this coal. This is called underground mining or deep mining. Coal reserves can be found in about 70 countries worldwide. The largest coal reserves are available in United States, Russia, China, Australia and India. The US is the international leader in coal reserves with nearly 30% of the world's supply. Coal mining was started in India in 1774. India now ranks third among the coal producing countries in the world. USA and China have two-thirds of the world's coal reserve. Types of coal. Coal is classified into four main categories based on the amounts of carbon it contains and the heat energy it can produce. They are lignite, subbituminous, bituminous, and anthracite. Among these four types, anthracite is the most desirable one due to its high heat content. First, lignite. Lignite is a brown colored coal of lowest grade. It has the lowest carbon content. The carbon content of lignite is 25 to 35 percentage. Lignite contains a high amount of water and makes up almost all of our total coal reserves. It is used for electricity generation. The other uses include generating synthetic natural gas and producing fertilizer products. Then, subbituminous. When lignite becomes darker and harder over time, subbituminous coal is formed. Subbituminous coal is a black and dull coal. It has higher heating value than lignite and contains 35 to 44 percentage of carbon. It is used primarily as fuel for electricity power generation. This coal has lower sulfur content than other types and burns cleaner. Bituminous. With more chemical and physical changes, subbituminous coal is developed into bituminous coal. Bituminous coal is dark and hard. It contains 45 to 86 percentage of carbon. It has high heating value. It is used to generate electricity. Other important use of this coal is to provide coke to iron and steel industries. Byproduct of this coal can be converted into different chemicals which are used to make paint, nylon and many other items. Next, anthracite. Anthracite is the highest grade coal. It has a very light weight and the highest heat content. Anthracite coal is very hard, deep black and shiny. It contains 86 to 97 percentage of carbon and has a heating value slightly higher than bituminous coal. It burns longer with more heat and less dust. Uses of coal. Coal is used to generate heat and electricity. It is used to make derivatives of silicon which are used to make lubricants, water repellents, resins, cosmetics, hair shampoos and toothpaste. Activated charcoal is used to make face packs and cosmetics. Coal is used to make paper. Coal helps to create alumina refineries. Carbon fiber, which is an extremely strong but lightweight material, is used in construction, mountain bikes, and tennis rackets. Activated carbon used in filters for water and air purification and in kidney dialysis machine is obtained from coal. Products obtained from coal. Coal, when heated in the absence of air, does not burn but produces many byproducts. This process of heating coal in the absence of air is called destructive distillation of coal. The destructive distillation of coal can be carried out in the laboratories, and the apparatus is shown in the picture. Observe the picture. Finely powdered coal is taken in a test tube and heated. At a particular temperature, coal breaks down to produce coke, coal tar, ammonia, and coal gas. Coal tar is deposited at the bottom of the second tube and coal gas escapes out through the side tube. Ammonia produced is absorbed in the water, forming ammonium hydroxide. Finally, a black residue called coke is left in the tube. Thousands of different products have coal or coal byproducts as their components. Some of them are soap, aspirins, that is tablet, solvents, dyes, plastics, and fibers such as rayon and nylon. The main byproducts obtained during destructive distillation are coke, coal tar, ammonia, and coal gas. Let's see the byproducts obtained during destructive distillation. The first one, coke. Coke contains 98% carbon. It is a porous, black, and the purest form of coal. It is a good fuel and burns without smoke. It is largely used as a reducing agent in the extraction of metals from their ores. It is also used in making fuel gases like producer gas and water gas. Next, coal tar. Coal tar is a mixture of different carbon compounds. It is a thick black liquid with unpleasant smell. The fractional distillation of coal tar gives many chemical substances like benzene, toluene, phenol, and aniline. They are used in the preparation of dyes, explosives, paints, synthetic fibers, drugs, and pesticides. Another product obtained from coal tar is naphthalene balls, which are used to repel moth and other insects. Next, coal gas. Coal gas, also known as town gas, is mainly a mixture of gases like hydrogen, methane, and carbon monoxide. The gases present in coal gas are combustible and hence it is an excellent fuel. It has high calorific value. Then, ammonia. The other byproduct obtained from coal is ammonia. It is used for making fertilizers such as ammonium sulfate, ammonium superphosphate, etc. Next, we are going to see an important topic, petroleum. The term petroleum is derived from the Latin words petra, meaning rock, and oleum means oil. It is a fossil fuel formed from the remains of ancient marine organisms through decaying process. Petroleum is a complex mixture of hydrocarbons that occur in earth in liquid, gaseous, or solid form. The term petroleum commonly denotes the liquid form, crude oil. But technically, petroleum also includes natural gas and bitumen, a solid form. The natural gas and the crude oil constitute the primary fossil fuels. Occurrence of petroleum. The chief petroleum producing countries are USA, Kuwait, Iran, Iraq, Russia, and Mexico. In India, petroleum is found in Assam, Gujarat, Maharashtra, and in Andhra Pradesh, Godavari and Krishna basin, and in Tamil Nadu, Kaveri basins. By drilling through the earth, the crude oil is pumped out from the well as a black liquid. Refining of crude petroleum. The crude petroleum obtained from the well is a dark colored viscous liquid which contains many impurities such as water, solid particles, and gases like methane and ethane. To make it useful for different purposes, it must be separated into various components. The process of separating petroleum into useful byproducts and removal of undesirable impurities is called refining. Let's see the steps involved in this process one by one. Separation of water. The crude oil obtained from the oil wells will have salt water mixed with it. As the first step, the water is removed from the crude oil. Next, removal of sulfur compounds. The crude oil will have harmful sulfur compounds as impurities. In these steps, these impurities are removed. Fractional distillation. Petroleum is a mixture of various constituents such as petroleum gas, petrol, diesel, kerosene, lubricating oil, paraffin, and wax. The process of separation of various constituents or fractions of petroleum is done by fractional distillation in fractionating columns. The process of heating a mixture of liquids having different boiling points and then separating them by cooling is called fractional distillation. Crude petroleum is first heated to about 400 degrees Celsius in a furnace. As the vapors of crude oil moves up the tower, the various fractions condense according to their boiling point ranges. The various fractions of petroleum obtained are given in the picture. Many useful substances are obtained from petroleum and natural gas. These are termed as petrochemicals. These are used in the manufacture of detergents, fibers, and other man made plastic like polythene. Hydrogen gas obtained from natural gas is used in the production of fertilizers. Due to its great commercial importance, petroleum is also called as black gold. Uses of petroleum. Products obtained from crude oil have a number of uses. Liquefied petroleum gas or LPG is used in houses as well as in the industry. Diesel and petrol are used as fuels for vehicles. It is also used to run electric generators. Petrol is used as a solvent for dry cleaning. Kerosene is used as a fuel for stoves and also in jet planes. Lubricating oil reduces wear and tear and corrosion of machines. Paraffin wax is used to make candles, ointments, ink, crayons, etc. Bitumen and asphalt is mainly used to surface roads. Next, fuel. Any substances that can produce heat and energy on burning is called fuel. We can use this heat for various purposes such as cooking, heating, and many industrial and manufacturing purposes. Some of the fuels that we use in our daily life are wood, coal, petrol, diesel, and natural gas. Types of fuel. Fuels are classified into different types according to their physical state. They are classified into solid, liquid, and gaseous fuels. First, solid fuels. Fuels like wood and coal are in solid state and they are called solid fuels. This type of fuel was the first one to be used by man. These fuels are easy to store and transport. The production cost is also very low. Then, liquid fuels. Most of the liquid fuels are derived from the fossil remains of dead plants and animals. Petroleum oil, coal tar, and alcohol are some of the liquid fuels. These fuels give more energy on burning and burn without ash. Next, gaseous fuel. Coal gas, oil gas, producer gas, and hydrogen are some of the gaseous fuels. These fuels can be easily transported through pipes and they do not produce pollution. Characteristics of fuel. An ideal fuel should be readily available, it should be easily transportable, it should be less expensive, it should have high calorific value, it should produce large amount of heat, it should not leave behind any undesirable substances. Efficiency of fuel. Any fuel contains carbon as its main constituent. During the combustion of fuel, carbon combines with oxygen and liberates large amount of heat. It is expected that a fuel liberates maximum amount of heat in the short time. The efficiency of a fuel can be understood from the following terms. The first one, specific energy. What is specific energy? It is the amount of energy produced by unit mass of a fuel. It is defined as the energy per unit mass. It is used to measure the stored energy in certain substances. Its unit is joule per kilogram. Next, calorific value. It is the quantity of heat produced by the complete combustion of fuel at constant pressure and normal conditions. It is measured in terms of kilojoule per kilogram. Next, let's see some calorific value of some fuels. The first one, cow dung cake. The calorific value of cow dung cake is from 6000 to 8000 kilojoule per kilogram. Next, for wood, it is 17,000 to 22,000. Next, for coal, it is 25,000 to 33,000. And for petrol, it is 45,000. And for kerosene, it is 45,000. And for diesel also, it is 45,000. Next, for methane, the calorific value is 50,000 kilojoule per kilogram. Then for CNG, it is 50,000. Then for LPG, it is 55,000. Next, for biogas, the calorific value is from 35,000 to 40,000. Then for hydrogen, it is 1,50,000 kilojoule per kilogram. Next, octane number. Octane number denotes the amount of octane present in petrol. The fuel having high octane number is called as an ideal fuel. Next, cetane number. Cetane number measures the ignition delay of the fuel in diesel engine. When cetane number is higher, the ignition delay is shorter. The fuel with high cetane number is called as the ideal fuel. Difference between octane number and cetane number. Octane rating is used for petrol and cetane rating is used for diesel. An octane number measures the amount of octane present in petrol and cetane number measures the ignition delay of the fuel in diesel engine. Next, octane number of petrol can be increased by adding benzene or toluene. Cetane number of diesel can be increased by adding acetone. The fuel with high octane number has low cetane number. The fuel with high cetane number has low octane number. Alternative fuel. The natural resources in the world have been used by man in rapid way and they will be exhausted soon. The traditional fuel that we use today including petroleum are non-renewable and they would be depleted soon. It is estimated that coal will last for 148 years, petroleum for 40 years and natural gas for 61 years. So we need to find alternative sources of energy. Moreover, fossil fuels emit harmful gases like carbon dioxide, carbon monoxide, and sulfur dioxide, which pollute the atmosphere. Burning fossil fuels also cause temperature rise in the Earth's atmosphere. Many believe that fuel which does not cause pollution is needed to enhance the quality of our environment. Some of the alternative fuels are biodiesel, wind energy, and gobar gas. Let's see them one by one. Biodiesel. Biodiesel is a fuel obtained from vegetable oils such as soya bean oil, jatropha oil, corn oil, sunflower oil, cottonseed oil, rice bran oil, and rubber seed oil. Then, wind energy. Wind energy is obtained with the help of windmills. When the wind blows, they rotate the blades of windmills and electricity is produced by the dynamo. Windmills are mostly located at Kayathar, Aralvaimuri, Palladam and Kudimangalam in Tamil Nadu. Next, gobar gas. Gobar gas is obtained by the fermentation of cow dung in the absence of air, that is, in anaerobic conditions. It mainly contains methane and a little ethane. It is widely used in rural areas for cooking and operating engines. Solar energy. Sun is the first and foremost energy source that makes life possible on the earth. Solar energy is the only viable fuel source of non-depleting nature, for sun provides a free and renewable sources of energy. It is the renewable type of energy without endangering the environment. It is the potential source to replace the fossil fuels in order to meet the needs of the world. With the advancement in science and technology, solar energy has become more affordable and it can overcome energy crises. Solar energy is a clean energy. With the minimum efforts, maximum energy can be harnessed using various equipments. Application of solar energy. Solar energy has wider application in various fields. It is used in solar water heater. It is used in drying of agricultural and animal products. It is used in electric power generation. It is used in solar greenhouses. It is used in solar pumping and solar distillation. It is used for solar cooking and solar furnaces also.